Hello Internet, welcome back to our snow shader. This is sort of where we're at after the two things. I've kind of updated it just to kind of give a little better example of what it can already do. So we've got two spheres kind of going around and then a guy doing a snow angel. That all works, so that's good. The next thing I want to do though is actually make the snow come back. We're not going to be able to simulate actual like snow hitting it, so we're not going to be able to connect like particles of snow to where they hit on the ground, not yet. But what we're going to try to do is just make it over time, the entire height of the snow raises back up to that normal level. And so that should hopefully kind of help it recover over time. That's sort of the idea. So this is in the same project as our grass shader. So we're going to use a compute shader for this. People have run into a few issues with compute shaders in the past. I've done a few videos on them. I'm still learning them myself, but I have a different idea. People ran into issues with the grass shader, so I think we're going to do a double buffer, which is effectively you take two frames and you kind of write to one and display the other, and then you flip those. So while you're writing to shader A or texture A, you're displaying shader or texture B. And then after you've finished writing to texture A, you swap that out with texture B, and now texture B is no longer shown, so you can write to that without writing directly to the screen. Seems compute shaders don't like it when you reference two of them, so what we need to do is we need a reference for the current state, and we need the new state. So we're going to have two textures for that, plus we're going to need our render texture for what this actually looks like. We're going to probably drop it so this no longer is doing this. Instead of don't clear, I want depth only. So it's still deforming it. You can kind of see, especially with a snow angel, you can still see him even though he's under the snow, but it's only deforming around him. It's not deforming anything else. And so we're going to pass that into our compute shader along with where everything else was, and then add some recovery over time. It should work, I hope. That's sort of the plan for this. So I've already opened all of this stuff up in Visual Studio. We have our grass. This is what we did for the grass shader. You can watch that video. There will be a link in the description for it. And yeah, so we're pretty much just going to cannibalize this and then make it work for this completely empty snow physics simulator, which is our C# script, and then our snow physics script, which is just the default physics or compute shader stuff. So let's start with this, because we're going to need to do some stuff to get this double buffer stuff working, and we can actually probably do most of that just with the compute shader we already have, so we don't really need to worry too much. I'm gonna grab this compute shader from here. Actually, it'll be easier if we just copy everything, and then I can just delete stuff. That way we're not kind of tripping over ourselves going back and forth between the two. This will just be easier. So we have a calculation engine, which is our compute shader. That's going to link to the snowphysics.compute shader. Then we have our initial input. I don't think we're going to need that. We have our springiness map, which that's from grass, which mapped how well the grass would recover over time. Max springiness and recovery speed. We don't need any of those. Reinitialize, we don't need that. Render texture, that's going to be the texture we rendered out. Get simulated texture, that just gets our texture back out. Physics simulation ID, believe that's our kernel. Yep. And then our simulated material is the material we're actually working with. So the simulated material is going to be our snow material. So I'm actually going to just call it that. I could have done that better. Let's do that. Snow material. There we go. And now we don't need to worry about any of that. There is a reinitialize step, which is actually going to initialize our entire thing. I don't think we need that because we can just initialize it to a white texture by default and everything should work. I'm like 90% sure it'll work. So one thing I want to check quick. No, we're not running this in the inspector, so we should be good. We're not running it in the editor. So I can take that out. And then we have our set float elapsed time. That's just how much time has passed. I'm actually going to copy this and put it here as well. And this way everything is just the same. So we effectively have two copies of our stuff. I don't actually need either of those anymore. I might use them for reference later, but I'm going to close them. That way we don't just get confused. So here is our compute shader. Here is what we're doing for the physics stuff. We have recovery speed, max springiness. I'm going to delete those for now. Springiness map. I don't think we need that either. And some of this stuff we'll probably add back, but it'll be slightly different, so we can just kind of figure it out as we go. Let's see, we have our flash input. I don't think we're going to want that either. We're going to initialize it to just a white texture, and then work from there. Or maybe not. Maybe it'll start black. I don't know what's better. Maybe it's best just to keep that for now, and we can do it. We can work through all of that later. What happens here? I'll just kind of walk through this so we're both kind of on the same page. First, we grab what our physics update is. These are the kernels, so this physics update has to align with this physics update and this physics update. So when you say the kernel, that's the kernel, and that just maps to this function. And so we need to get that ID because that's what we're actually going to reference it as. And then we grab one for our flash input, which just overrides everything with a specific texture. We create a output texture, just a render texture to render our compute output to. We set the height and the width of it, just so we can actually find positions in space. This was for the grass, which is why that was needed. I don't think it's needed here because everything is in texture space. So we probably don't actually need the width and the height. The input and result are just going to be the input into the texture and then the output texture. So this is just setting that texture we created, the render texture, as the result, so that when we write to the result in our compute shader here, we're actually writing to that render texture so we can actually see it. Then, after we do all of that, we actually are going to call this flash input. That's what dispatch does. It actually invokes a compute, the compute shader with the specific kernel. So that's what this is. And then these parameters, which are just fun. Those are the thread groups. I am not going to be able to explain those right now. But anyway, that is that. Great description. And then after we do that, we set the texture for our results for the input. How does this happen? So we set the texture. Oh, got it. Textures are set for per kernel. And so we're actually setting the texture for the result here. And so what ends up happening is the result texture gets set for our new physics simulation. Instead of the flashing of the input, we're actually setting it to the physics simulation and actually using that here. Then we just set up our material to actually use the output texture that we generate as our deformation map. That all hopefully made sense. It was kind of long, but after we do that, it's just setting in elapsed time so we know how much time has passed in our shader, and then we can actually simulate that here. Part of the issue we were running into, and we're going to run into here as well, is going to be floating point errors. These aren't super precise numbers. So if we recover over a very long period of time, we're actually not really going to see any change because it's going to just round down to 0. And then that change just gets neglected over and over again. And so you won't actually see anything. So that's one thing I'm trying to figure out how to fix. I have ideas, but I haven't had any success yet. So if you guys have ideas on figuring out how to store bigger ranges of things. I was assuming a high dynamic range thing would work, where you could actually store more than just 8 bits per color channel. It didn't work. I don't know what, maybe I was doing something wrong. But anyway, that's not really relevant to this. What we need to do is get rid of the height and width, not really needed. Get rid of the springiness map, that's also not needed. Get a simulated texture, don't really need that. Physics simulation, snow material, got that. On our snow material, we actually need, I'm going to go back here and grab our material, because we actually need to grab the shader and use the deformation map. I think it might actually be called that. But I just want to check quick. Once it figures out what it's doing. Probably shouldn't have that just running. Let's see here. We called it a... not displacement. Displacement texture. There we go. So this way we set our displacement texture this way. This isn't actually going to work. So again, with double buffering, we have one that we write to and one that we render to, or one that we read and one that we write to, and then we split those back and forth. So we actually need to do that here. If we don't, we'll actually only get updates every other frame, which probably isn't what we want, especially since we're calculating it for every frame. So we need this down here, but I'm not going to do that yet, because for this double buffering thing, that's not how you do an array. There we go. So we're going to create a render texture array. This is actually going to flip between the two. So there's actually going to be a private int, which is going to be our texture index. So this way we could actually, I don't know if there's any point to this, but you could actually add additional buffers if you wanted to. And then all we're going to do in here is take this from there, drop it down here into our fixed update when it's actually getting called. And then instead of doing this texture, we're going to do texture I++, texture index, sorry, ++. So this actually increments our texture index. And so that will just count up to infinity over time. We don't want that. What we do want is to say the texture index is equal to the texture index mod 2. So this, if it just takes the remainder. So if you get up to 2, it rounds that back down to 0, and we just keep repeating. So we go 0, 1, 0, 1, 0, 1. And that way we just flip between those two. That should be about it. We have a width and a height that I need to set. So I'm actually going to need public int render width, public int. I'm not actually going to do this. Sorry about that. Instead of this, why don't we, so we're capturing this render texture, right? We actually are already capturing that as part of our camera input. And so what we can do is, instead of that, let's grab our camera input and use that's width and height to actually calculate everything. So whenever we're trying to grab a width or a height, we can just use that this way. So doing all of this stuff, I need 2 of these. So for int I equals 0, I less than 2. Let's not do that. Let's do a texture.count length. Getting my Java and C# mixed up again, but there we go. And then instead of writing to texture, we'll just write to texture I. So this part gets a little bit more confusing just because we're actually writing into an array now instead of not. But it sort of works. So there we go. There's that. We'll return a texture array there. Get simulated textures. That's probably not the best way to do that. Let's actually texture and we'll do the texture index. So this way, there's still a way to just pull out the currently active texture. I think that just makes sense. I don't know why you need the buffer, but we could add that if we need it. So now that we're doing this, we need to actually flip between the two. So we're going to have another input, calculation engine, set texture, overwrite. We'll call it the previous state. I think that makes sense. And that's going to be our texture I. I++ mod 2. Not plus plus. Don't want that. You know what? There's a way better way to do this. I was talking about having a way to get the buffer. We could just do that here. Get snow buffer. Sure. And we'll just call this snow texture. And so this is going to be the texture index plus plus, can't do plus plus. Why do I keep doing that? +1 mod 2. So effectively, we only have 2 indexes. So the first one is going to be this texture index, which is what we're currently on. The next one is going to be equal to this. So it's just going to be the opposite. Since we're incrementing it by 1 and then taking mod 2, the first, if texture index is 0, it becomes 1. If it's 1, it becomes 2, which gets modded down to 0. So this way we just have both of those. So now that we have that, I don't need to do all of that. I can just do, let's just call this the snow buffer. What am I doing? JavaScript or Java stuff. Properties. They're a thing. We can use properties. There we go. Okay, so we have our snow buffer. That's our previous state. That's probably not how we want to do it. So how is this working? This kind of matters because otherwise we'll be one state behind every time, which doesn't really make any sense. So what I'm trying to do is figure out how to get what the previous state should be and what the current input should be, or what the result should be. Because we are setting our display texture of our snow material equal to the current texture, which I'm just going to snow texture. So we want the result to be the snow texture of that. Yes, that's way easier to follow. Okay, cool. So we can do all of this in here. I actually want to put these down here. That's not going to work. Physics simulation ID. There we go. So what this is going to effectively do is swap between the two, back and forth. And so as we are, let me just fix this error because it's bugging me. But so this is going to swap between the two, even though we don't have anything. Our actual buffers are changing because of this code here. And so our snow buffer and our snow texture are actually flipping places each time. And so we want a result to be written into our snow texture. And then we're going to set that as the material, or as the texture for the material from our output. So it's kind of hacky-ish, but it should work, hopefully. So there we go. Set texture, result, all of that fun stuff. We don't actually need this because we're doing it down here now. So I don't actually need to set the result. Or I shouldn't need to. Yeah. And then let's pull our input out of there. Set that for our physics simulation ID. And so this way our input gets pushed, our camera input gets pushed into the input for our physics simulation, the actual simulation we're going to do. And then this part can just use the snow texture. So we're just using that's width and height, and we should be good. So all of these widths and heights that I'm using, those are all coming from here, all these generated textures, but all of those are actually coming from this camera input. So the camera input, the size of our render texture that we initially use, is actually going to determine how all of this works. And so you're actually using 3 times that amount of memory in space. So I don't know if that's good or bad, but that's just how it comes out. So theoretically, this is all good. So we have an elapsed time, a previous state, a result, and an input. Those are like the 4 things that we really need to worry about. And 3 of those are textures. So we're going to have an elapsed time. Going to get rid of those 2. A springiness map, we don't need that. We have our input, our previous state, and our result. So that can just replace that. That can go away. And I think we're good. Then everything else is just going to be texture reads, I think. And yeah, I think we should be good. So this is currently just flashing everything to be a specific color or to read from a texture. I'm not going to do that. I'm actually just going to set this to all be 1s. We could actually probably do this easier, but this way we just get to make sure it all works. So we should get a white texture out of this. If we don't, it's not working. So I can actually leave all of this here. I'm gonna comment all of that out. There we go. And we just want the previous state .id.xy. So this is just the xy position of where we are. We're just going to grab that and use it here. Does that work? I think I might need the width and the height actually, because I don't think I'm not getting UVs, so I don't think I can just read out of this texture. I can do that with this read write texture because that's how that works. But I don't think I can do a text 2D LOD. I don't think I can call those functions without a UV. I don't think that works. So we may actually need the width and the height, which isn't that big of a deal to plug back in. But for now, we don't actually need it. This physics update is just a no-op. It's actually just copying between the buffers. So it should just keep rendering a white texture if I did this right. And then we can actually use this state later and hopefully get it to actually do what I want. But that's sort of the idea. Actually, I'm going to initialize this to red just as sort of a way to make this prove itself, to show that it's actually working. We're going to set this and we're going to use the swizzle operator. So instead of RGB, which is just normal colors, we're actually going to do green, blue, red. So red just shifts to the back. And then that way it should just keep cycling around. It should do sort of a cycle. So the red color becomes the green color, and the green color becomes the blue color, and so forth. So this should just cycle between red, green, blue in that order. And hopefully it does. We're going to need to make this a float 4, because otherwise it's not going to work. And we can actually just do it like that. There we go. That was easy. So hopefully that's all good. Everything should be cool. Let's see if it actually works. Fingers crossed. If not, then I'll figure something else out. But this should, as far as I can tell, work. Isn't that reassuring? That's pretty reassuring. All right. So, snow simulation. We're just going to create a separate game object for this because I did already. And then let's attach our snow simulator. That's actually, before we do all that, I need to actually attach my compute shader here. We hid it in the inspector, so you can't actually change it anywhere but this screen here. So if I actually attach this to an object, it's not going to show up. Yeah, so you don't see that thing there. So we need our camera input and our snow material to render out to. For now, I'm actually just going to grab a material. That took longer than expected. There we go. Actually, hold on. This is writing out to the display texture. That's going to be less useful. It's going to write out to a display texture, which I'm not going to see. But I actually don't think that matters. I just need this here, and we'll just use our snow for reasons. Snow tessellation shader, sure. That all works. It should be fine. We don't actually care what's going on here. What I actually want to see is we will see two textures pop up here. I want to just make sure that those are not the same color. One should be like green and one should be red or something like that. So we need to grab our render texture from here, not there. There we go. No, why can't I? We can't choose that as a, that's weird. Oh well. I guess we're gonna change, oh. Okay, so I had that set as a texture 2D, which is actually a subclass of texture. And the problem with that is render texture is also a subclass of texture, not of a texture 2D. So we need a texture so that we can actually plug in our render texture from our camera. Otherwise, this won't work. So now, once that recompiles, I should be able to actually pull my render texture on and actually attach it to this camera input, and everything should just kind of fall into place. If I can select the right thing, there we go. So now we're just getting that camera input. The only thing that's going to do here is set the size. It's not going to do anything else. We're not reading it, we're not doing anything. So we broke. Cool. Things have broken. Physics update not found. Find kernel failed. And array index out of bounds. So physics update doesn't exist. Why not? Pretty sure it's right there. Okay, that's interesting. Next thing is a kernel error. That's the same issue. And then array index out of bounds is because I never initialized this texture array. Well, we can fix at least one of those. So this is going to be equal to texture equals new render texture array of 2. That's at least one of those issues fixed. Don't know what about the other two. We're gonna have to dig into those. I don't know. Array index is still out of bounds. What? Well, that doesn't make any sense. That doesn't make any sense at all. What if I initialize it up here? Just out of my own curiosity. I suspect we may have run into an issue because that texture there is public, and so it's expecting it to only be 0, just because of Unity. So if I set that to 2, we're probably good. But see how it's initializing itself back to a size of 0, even though we have a texture of 2. Pretty sure that's our problem. Let's see. If not, then something else broke. No reference exception. We're making progress. Set texture, previous state. That's the wrong way. There we go. So previous state couldn't be set. Because of a null pointer exception. Well, that's not helpful at all. Huh. And I don't think it's because our snow... Oh. Let's move this to our awake call. What may... I don't think that would happen. That doesn't make any sense. It shouldn't be calling our update before it calls our start. That doesn't seem right. Apparently it was, because it's gone now. So what could have been happening is we could have been hitting this fixed update prior to our start being called, which means none of our textures would have existed, none of our kernels would have been set, and none of that would have happened. And so if that happened, then all of this would have failed. And apparently that's what was happening, which is weird. But yeah, that's what happened. So, all right, now I need to figure out why this physics update isn't being found. We have it here. There's our physics update and our flash input. Let's name this something else. Call it like snow physics update. And just for kicks, snow flash input. I'm just curious if this is going to even have any effect. I'm kind of hoping no, but kind of testing things out, figuring it out. So, shader error. Array, matrix, vector, or indexable object type expected in index expression. Our previous state is a texture, not this. So we're back to our width and height issue. So let's feed those into our shader and move on from there. So calculation engine set float in float, sure, float physics simulation ID width, and we'll do our snow texture dot width. That's not how you do that. There we go. And we'll do the same for the height. It may be being angry because these are ints, not floats. Takes 3 arguments. Well, there you go. Okay, so that isn't needed. Yeah, so you only need the texture ID or the kernel ID when you're working with textures. Good to know. So width and height are coming in as floats. So this is our width and our height, which means we actually need to index into this. So text 2D lod of our previous state. We can't index into it like that, so we're just going to do a float for of our x divided by the width and our y divided by the height. The z and w don't really matter, so those can just be zeros. I'm just copying it from right above it. And then we're going to take the same swizzle bit that we were doing earlier. So that should just solve that problem. And we'll see if there's any others, but I think we're making progress. I imagine those compile errors are what were causing the kernel not to be found, but I could be mistaken. So let's try this again. Same issue. Physics of, oh, we changed those. Snow and snow. All right. There we go. So let's run this again, see what happens. Or I'll just pause and a stopped game, but there we go. Cool. So it seems like you can't have duplicate kernel names even across different files. It seems like that was what was causing that issue. So good to know. Now let's see what our snow simulation has. We have two of these render textures. That one's black. That's not a good sign. That one's also black. Also not a good sign. Well, that was a good failure. All right, I'm gonna try this one more time. I'm gonna stop it the first time though. So it should only do one frame. Black, and the other one's gonna be black as well. Cool. I mean, not really, but so we've rendered our result out. It's gone to our state, and then we've used that to draw our next one. Seems like I have broken something. And I'm pretty sure this, both of them are kind of suspect at this point. So I'm actually going to eliminate that one. There we go. So we're just not going to do anything there. All we're going to do is render our flash input. So that hopefully is just going to get us a red texture. If we're not getting a red texture, then we know what's going on, or we have a better idea. So there's that. Doing the same thing. Snow simulation. Red. Good. Very good. This should be uninitialized. Perfect. So we got red. And then I imagine what happened is we iterated, and then the black overrode the red. That's the assumption I'm making. I don't know if that's correct, but I don't have any way to prove that it isn't. So what would cause that to happen? I don't need to do it that way. Let's do that. There we go. So we have a state. We've rendered into the result. And then the result becomes the previous state. I wonder if it's because we don't flip them during this bit here. So if I, just out of my own curiosity, were to set it this, because what I would assume would happen is we would initialize this, and then our fixed update would get called, and would do the same thing, but it would pull, it would do this, which would use our previous state, which is null, to write to this, because we didn't flip the two states. So if I write to our snow texture as the or when we flash, so our result is just because it just can be. I think that's probably the right way to do that. So let's hope this works, and we'll see. There we go. Red's promising. Blue, cool. Red, awesome. Okay, so that appears to be working. We appear to be having at least a little bit of state. I'm not going to go super in depth and verify that that's working. I at least know that it's writing to both of those textures. So now that we have that working, we just really need to take this to the next level, because all this is doing right now is just flipping those colors. That's not what I want to do. So we want a previous state equal to this. So float for previous state equals that. So that is our previous whatever we got. And we can just write that right out. So this will just fill everything with red. Not really interesting. But now we can take our input and use that as well. And so I actually am only going to want the red channel from our input because that's our depth. So we're going to grab the depth from that, use our input, and there we go. So that's the state and the depth at a specific location. And so given an elapsed time, we can increment that. So our previous state is just a really basic function. It's just going to be a previous state. We want to trend towards 1. So trend towards Actually, that's the opposite of what we want to do. We want to trend towards 0. So previous state equals what do we want? Equals our previous state plus or minus, actually, our elapsed time. But I want to do a float for of our elapsed time, and the rest can be zeros. We probably don't need that all to be in a float for. We only are working with one channel, really. All the other ones for now are just discarded. We don't care about anything but the red channel. But for this, we can use everything. So this is our previous state. So that's going to move it slowly towards 0. But what we want is we want the maximum of that previous state and our depth. So if our depth is super low, like if you're standing on it right now, we don't want to recover there. Or if you're like picking your foot up, it will recover up to your foot, but not below it. And so that's sort of the idea here. So that should effectively recover. It's going to recover super fast because this elapsed time is real time, so it's gonna recover pretty quick. But that should be fine for just proving that this function works and actually does what we want. So the only thing I should need to change here is instead of this new material thing we're using, we don't need that anymore. What we do need is our snow tessellation shader to be there. So we're going to take what we're rendering from our camera, pass into this, and do some fun math, get a result out, and set it to our snow tessellation, which means we shouldn't see any displacement unless our compute shader is working, which hopefully it is. Or it's doing the exact opposite of good. We wrote red. That's what that means. But that's not a good sign. What? Hold on. Why can I see the depth in the other channels? That's not right. There's red. Did I flip this? Am I doing that thing? No, because we were getting red out. What? I'm totally lost now. I thought I understood Oh. Got it. I'm being silly again. Ignore me. Okay. So we're doing float 4s and stuff. Let's just take that out. There we go. So this is our red value, right? I think we can actually just do that. Let's try that. See what happens. Worst case, it doesn't work. It didn't work. So I can't do that. We're going to revert that and do a float 4. There's our red channel. And everything else can be our previous state.g. Let's do GBA. The Game Boy Advance color. And so that is going to be our previous state, which is just going to be the max of this red channel. We need an actual period there. That probably is why it didn't work, not the other thing, but whatever. So max for the red. Everything else is just staying the same. And that kind of looks somewhat promising, maybe. Errors. Errors all over the place. I wish it would give more than just, oh, this didn't work. Probably has something to do with me doing that. There's parentheses being wrong all over the place. There we go. Okay. I think I've probably actually done this correctly now after the 100th time. Clearly not. Now we just have a red texture. So it should start all the way depressed because we're initializing it to red here. But then over time, I would expect that to come back up unless the elapsed time is super small, which actually might be the case. I don't know how to fix that if it is, because, hold on. Let's start this. I'm going to turn on the stats and see what kind of frame rate. No, that shouldn't be an issue. We should at least be seeing something, I would hope. But we're not. So our snow simulation is just red. That's not good. That's not what we want. So if I set that to just 0, it should be at the top now. And it is. Good. So our computator is actually working. It's actually rendering to that because that's where all of this information is coming from. So that's good. But what happens if I disable these balls? So if I turn that off, I would expect it to recover over time. That's not happening. So I'm pretty sure this is an error we can fix because we have this. It's sort of what we want, but I'm expecting this little red angel thing to be dimming over time. It should be getting, especially those outer rings, should be getting less bright. And unless I'm very wrong, they're not. 100% certain they're not. So yeah, I would expect it to go almost immediately because we're down to the 1 second thing. So either this is wrong, which I don't think it is, or we need a multiplier, which we can do multipliers. Let's just for kicks, throw on an extra 100. Why not? So now that is something that I would have expected to make an immediate difference. I don't think we're recovering at all. I think our function's wrong because that doesn't make any sense. So we're taking the maximum value of our red channel. Oh. Sorry, I just wasted everybody's time because all I needed to do was hit this depth button. Don't yell at me in the comments. I just needed to flip that. Duh. We didn't need to probably change any of that. So it's going to recover super fast because I changed it to 100. I didn't, actually. 0.1. We need to slow this down a lot now because it's going to recover real quick. And it's definitely displacing, but it's displacing almost immediately. Almost to the point where I'm questioning if we're actually correctly passing the state across. But we had to be because we were flipping between the textures. Right? So that has to be our state passing across. So then why is this going so fast? I'm going to remove that for now. We should get, with this, we should get the same result as we were previously with the saved depth. And we're not. So we're not saving a state. There's no state here. That's a problem. And I don't really know why we're not. Didn't we show that that's exactly what we were doing? Well, that might be part of the problem. Our second texture has nothing in it. Huh. That's not good. So this is going to configure both of the textures. We should be flipping between the two. We're not, because when I was deleting everything, I skipped the part where we increment the thing. Whoops. Okay. Bunch of errors, but that's all right. We've now, how many times am I going to say it's finally working? Oh, that is super cool. That's not what I wanted at all, but I'll take it. That's neat. We have waves. Ah, that's cool. It's not what I wanted at all, but yeah, it's neat. I'm kind of curious why it's happening. I think we might have some floating point errors that are causing it to kind of shift over time. That's probably less good. But let's see here. Is there any way I can fix that? Probably not. It might just be the smoothing. So these textures are going to have texture I anti-aliasing. Is that what I want? I don't think so. Not that. Let me quick. There's an easier way to find that. Texture. What are you doing to blur the things? Filter. So it might be using a filter, and I probably want that, but I'm not. I'm gonna get rid of it because what it might cause this to happen is it will blur between the two nearby pixels based on where you are in between the two. And that's not really what we want because we're using this to look up data. And if there's floating point issues like we appear to be having, that's actually going to just slide everything. So that's not how you type. Filter mode point. This might fix the issue. If not, I'm going to undo it because I would prefer filtering, but okay, cool. So that was the issue, or it fixed the issue. So we still don't have the snow coming back because I took it out. I'm going to put it back and see what happens. It should take 10 seconds for it to completely recover. Haha, it works. It's not quite 10 seconds. Yeah, it should take 10, but anyway, it's working. There's some tweaks, obviously, but hopefully this works. So if you guys have suggestions for how to improve this, I know this probably ran long. It looks like I've been recording for like an hour, but if you guys have suggestions on how to improve this, or you think you have ideas on where we should take this, this is sort of a basic prototype. We can slow this down a bunch, not a bunch, but a little bit. We're going to hit some cutoff where it just stops recovering like this. And that's just because floating point errors, it's just dropping all those extra decimal points. And so there's actually nothing, there's no extra data there. We're not actually adding anything else. So we need to figure out a way to fix that because the grass shader has the same issue. And I'm sure there's ways we could just increase the texture resolution or the color depth. I think that should work.
According to wikipedia.org, color depth or color depth
Yeah.
Also known as bitdepth.
Can you?
Is either the number of bits
I'm
used to indicate the
okay.
color of a single pixel in a bitmap image or video frame vector, or the number of bits used for each color component of a single pixel.
Thanks, Cortana. Anyway, okay.
You'll find info on that word in your Cortana app history.
Thanks. Yeah, so that happened. Now we're gonna move on and make this better. We still have all of this, and it doesn't recover. So I don't really know entirely how to fix that, but that's the plan. So if you guys have suggestions for that or other ideas on how to improve this, I'd love to hear them. I think that we've gotten it to sort of the point where we're kind of at that barrier-ish of it sort of recovers, but it goes so fast that it's not really the effect that you'd want necessarily. And so figuring out how to slow that down is sort of the next step. So I have rambled for way too long now, and Cortana did not help. I shouldn't have said that word. But anyway, I will leave this here. If you guys have suggestions, let me know. If you are interested in more on the channel, think about subscribing. We do a lot of content. I try to do a video every day. That hasn't really been happening, but hopefully I'm working towards getting back to that. It's work and stuff has just kind of taken more time than I had hoped. But anyway, more stuff soon. More of this, more of everything. But until then, I'll see you guys in the next video. So I did that backwards, but whatever. We'll roll with it. Yeah. See you guys next time.